Hello, VibeCodelicious people, Basil here. So we're continuing our live stream series where we are working on the Context Bonsai plugin. Now, at the start of this one, I want to go into the instructions, the plugin instructions that tell the LLM how and when to use Context Bonsai. The reason for this is that over the past couple of sessions, we wanted to do a bunch of side projects, and within those side projects, we were specifically looking for when the LLM chose to use Context Bonsai. And we found in yesterday's session that it was using it at a particularly inappropriate time in an inappropriate way. And that is that I have this development orchestration system where an orchestrator is given an implementation plan, and the implementation plan usually has several stories within an epic, and it's asked to orchestrate that. It does this by launching a developer subagent and giving the developer subagent a list of files that it should read to understand what the plan is, how to act as a developer, and whatever additional project details like coding standards or whatever else is needed to complete the task. So it launches the developer agent, gives it this information. Then the developer agent, let me fix this. Then the developer agent reads the documentation that it's asked to read and starts working on its plan. But what we found is that when Context Bonsai plugin is available, then immediately after it reads all of those documents, it decides to prune away the knowledge that it has just read, which is unfortunate. It actually needs those developer instructions. They're very important for it to complete its task appropriately. It also needs the details that are in that plan. Those are not unnecessary details that can just be pruned away and summarized. So we need to take a look at the LLM instructions there and work with it. And then in much previous sessions, or sessions that are like several days before all of this, we have done some work with the LLM where we were demonstrating Context Bonsai and working with the LLM to go through a sequence of steps that show how Context Bonsai works and that it is actually working. And what we found a couple of times is that the LLM thinks of its own memory more like human memory than like LLM memory, and it needs a reminder about how LLMs operate so that it stops thinking that it can just prune things away but still remember them afterwards. So what was happening were we were still debugging our Context Bonsai plugin. There were times when we would ask it to prune information away, but it was still able to answer questions that had details that were in the supposedly pruned away message, but those details should not be knowable by the LLM at that point. And if you ask the LLM how it knows it, what I'm hoping is for it to cite a message where that was stated explicitly, and it would have been the message that was pruned away. But instead it says something like, well, this message was pruned away, but I still remember it. And that means that the LLM itself is thinking about its memory more in terms of human memory rather than how it actually works, which is that there is a context that the LLM receives, and it's asked to continue that context. Now, the context is simply every message and tool call results that has happened in the interactions with the LLM. So yeah, it's just a sequence of messages that the LLM reads and it attempts to continue. So what the prune does is it will mark certain messages in the conversation as archived locally in our local harness. And that means when the harness sends the stack of messages up to the LLM, it just omits any message that's marked as archived. So when the LLM receives the conversation, those messages simply are not present. If you said something in a message that was pruned away, the LLM has no way of knowing. It doesn't actually have memory between the messages that you send, except for, well, every single time you send the entire conversation. So if we take messages out of the conversation we're sending, there is nothing in the LLM that should remember that. So because we've seen that behavior, because we see the LLM thinking about its memory in inaccurate ways, I think that is the most likely way that we can help the LLM not prune away context that it still needs. We do also want to be careful because on the other side, there are plenty of times where we want the LLM to be more aggressive with its pruning. So there's this balance between we want it to do it more frequently at times when when it is appropriate, and less frequently when it's not appropriate. But we're going to start with this first part of doing it less often in inappropriate times, because that's more damaging than the opposite. The opposite, if it just simply isn't aggressive enough with pruning, it just falls back to the normal behavior that people are already used to with coding agents, which is there simply is no pruning. The entire conversation proceeds and proceeds and proceeds until it's too large for an LLM to handle, and then an auto compaction happens. So that is simply what will happen if it's not aggressive enough. So that's sort of a secondary concern. The bigger one is that we give it instructions and then it prunes away its knowledge of those instructions, which is going to cause sort of catastrophic results. So let's take a peek at the Context Bonsai project here. We're working on sort of several things all at once on Context Bonsai. One is observability tooling. So we've written a tool that will let us list all of the OpenCode sessions and tell us how many Context Bonsai calls were made during that session. And then we can look at any one of the Context Bonsai calls and get the set of messages that happened before and after that call, so we can judge whether or not that was a good time to call it. So that's what we're working on here in this tab. And most recently what we added was we want to see more arguments to the tool calls that is happening, because we did catch it when the developer agents first launched. It did Context Bonsai almost right away. And I just wanted, what we saw from our observability tool is that it did a lot of read calls, but we couldn't tell what files were being read. So we augmented the script so that it can tell us what files are being read, and then we'll be able to tell what was being pruned away. So we actually might run this because we haven't done it after adding that feature. And in this tab, we're working on getting Context Bonsai to work on stock unmodified OpenCode. Right now, we have a modified version of OpenCode that has just a handful of changes, just enough to allow Context Bonsai to work. But I think that we can get there. I think we can make Context Bonsai plugin work without a modified OpenCode, because rather than working off of a modified OpenCode, it will at runtime load OpenCode's own code and monkey patch in the changes that we need to support what the plugin does. So that's what we're working on this tab. So now we're going to have a third tab for Context Bonsai, and this is where we're going to explore the instructions that the plugin comes with. So let's launch a new LLM. What am I using? OpenCode. Okay, let's see. This directory is the Context Bonsai plugin. We've found that the LLM is inappropriately pruning context. Oops. Let's go use that observability tool to get an exact example of what bad is happening, so I can feed it to this LLM so that we can start a discussion about what's happening. I think if I go like this, here we go. Here's a previous one. Let's go like this. Okay, so here we are pulling up a session that had several Context Bonsai prune calls, and we're showing the actual arguments that were given to Context Bonsai prune, as well as several messages before and after the prune call. So what I want to see, I think, is probably one where it says it read something. So let me see if I just can see. There we go. That's exactly what I'm looking for. Read subagent instructions in story context. Then inspected some files to locate the exit code mapping gap. Identified that the overlay background read decode errors were thrown as plain error and reached the top level catch as exit code 1 despite carrying invalid input text. Index terms. Okay, so it gave some index terms. So when Context Bonsai runs, the LLM picks a range of messages that should be pruned, and it provides a summary about what's in those messages, and it also provides a set of index terms. And the summary and the index terms are there specifically in case the content that was pruned away is actually needed later. There's a separate tool called retrieve where the LLM can see the summary and decide, wait a second, there was something in there that I actually need. I will pull the information back out. What it's deciding to carry forward. So what this effectively means is that when you prune, the LLM is responsible for understanding within the messages that are being removed what actually needs to be kept moving forward through the conversation, so that you can continue working. So here's what it decided was going to be needed later on as it continued working. It needed to know that it read some instructions in context. It needs to know it looked at these particular files, and what it found out is that these read decode errors were thrown as plain error and reached a top level catch as exit code 1 despite carrying invalid input text. So that's what it decided it needed to learn out of whatever messages got pruned away. So the from pattern includes a message ID, and the to pattern includes a message ID. Oh yeah, this is another thing. Maybe we should focus on fixing this first. We originally built Context Bonsai in a way that allowed the LLM to turn on message IDs, which means when it receives the conversation, every single message is prefixed with an ID. And then it calls the prune again, and it gives it the specific message IDs of from this message to this message is what we need pruned. In order to require fewer changes from the core of OpenCode, we changed this to work more like the Agent Harnesses edit tool. When Agent Harnesses edit files, they provide simple sort of search and replace strings. It's given a string and says replace that string with this other string. So it can do something similar with the Context Bonsai. Rather than just picking message IDs, it can just pick a unique string that matches that one message or what the two messages that identify the full range. But we didn't complete the change. There's still instructions in there that tell it to turn on message IDs as the phase 1, and then recall it, giving it the message IDs as phase 2. So that's maybe something that we should fix first, because that causes a little bit of churn. It starts doing things kind of the wrong way. And I bet that this prune call failed. We might also want to augment our observability tool to show whether the call succeeded or failed. Let me do further backwards, searching to find instances of read. Is that really not finding anything? Oh, get rid of quotes. Not there. Not there. Here's another example of the augmentation we made to the tool just yesterday. Before we could run this and all we could see is that it ran the read tool. Now we can see exactly what arguments were given to the read tool. So it read this file, and we can see how many, I guess that's bytes or lines that it limited the read to. This one looks like a bad one. So called prune. The from pattern is it's rereading the plan, the implementation plan that it actually has to implement, and the to pattern is a list of file. No, to pattern is just readme.nd, which may be the result of a tool call. The summary that it says is it performed a repository-backed recheck of the true wall geometry plan by inspecting the plan itself in the current render, CLI, schema, tests, fixture baselines, hash update script, Poisson MST generator, and README rendering docs. It's established that the plan's locked defaults now map directly to existing contracts and known migration points, enabling a no blocker verdict with concrete file evidence. Okay, so yeah, I'm not really sure I'm satisfied with this README based on what it actually did here. Let's see. Well, I don't think we're gonna find this this phrase, but let's see if it shows up. Recheck. Text recheck. Oh, we do. Okay. So that was a user message. I told it to recheck the plan for a missing detail. Then the assistant called read on several files. It did the plan here. It looked at these two code files. And additional code files. And some package.json for some reason. It did some searching for things related to that change we were trying to make in the image to maze project. And then it ran the prune tool to prune away everything it just did. And the information it left behind was that it's telling itself that it checked all these files and made a determination. Let's see. Prepared to report whether any blocking details remain based on those references. So it read those things in order to create a report, but before creating a report, it's deleting its knowledge of those things. I wonder what happens after that. Okay, then the assistant has a reasoning block that says no blocking gaps remain after the refinements. The plan now makes the key implementation choices explicit. Which is, I guess, how it summarized what it looked at. This established that the plan's locked defaults now map correctly to existing contracts and known migration points, enabling a blocker no blocker verdict with concrete file evidence. Interesting. And that's the end of the sequence of messages that we get around that particular context bonsai call. Then is a separate context bonsai call. Maybe that is okay. In that case, maybe it's fine. We did see it launch developer subagents and then immediately prune after developer subagents launch. So let's see if we can find one that does that. Or maybe we can just specifically generate one. There's a way to list sessions in OpenCode. I can just do this. Oops. Now I would like to see a developer subagent in here. Oh, this is doing sessions for the current directory. I actually want sessions from the image to maze project. So let's go over here to the image to maze project. See if we can find a session where it launched a developer subagent. That might be one. Let's go open it, go to the very top. You are a developer subagent. Let's take a peek at this one and find out if this session ever used the Context Bonsai stuff. So I'm going to take this session title, then go back over here and use our tool to look for this. Oh, it's not finding any. It would be nice to somehow from here get our current session ID. What if I rename the session? Well, that's still going to be the same. Well, maybe simply renaming it is going to cause a database write, a message database write. Oops, go away. That makes this succeed. Okay, let's actually figure out why it can't find this one, because this has been working for us. We've been able to just copy the title and then search for that title and find it. It may be not working because this is a subagent session rather than a parent agent session. So we'll find that out. Here is where we're doing development on this. Then this session is the title of a subagent session. So that's possibly why it's not working. Can you take a look? Great. In the meantime, because we specifically are looking for those times where it called prune pretty much right at the beginning, we can just visually look for that. So here are its initial instructions. Then it reads all the important files, reads important code based on the plan, what it has to do. Reads some test fixtures, looking for uncommitted changes, planning parallel test execution, so it runs tests. Interesting. Okay, then now it's testing the command itself. Ooh, that's a giant tool call output. That would be very good to prune away. Inspecting the output of the tool. All right. then running the full bun test suite. Oh, and then it stopped at that point. That's probably because we killed off whatever the parent was, and we had the parent stop, and that stopped all of the children. So we actually do not see any prune call in here. Read, 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 read. Bash tool, bash tool, bash tool, bash tool, bash tool. A read tool, and a bash tool. Okay, well, this is not a good candidate. Let's look for another one. This would have been Tuesday. No, Wednesday. So, oh, it's actually not showing any Wednesday sessions. What? Is it really? It's Thursday today. It was definitely yesterday that we did a bunch of stuff. Huh. That's concerning that it's missing a lot of sessions. Or maybe those sessions were touched today, and so these. No, there had to have been more than that. That's peculiar. Well, let's quit this session. Okay, don't need that anymore. But here's the parent session, and this is going to have a whole ton of child sessions or subagents. Actually, let's go to the parent and let's go left. I think is the most recent. Is this a developer? No, that's a reviewer. That's a reviewer. And that's a plan reviewer. Not that one either. Nope. So it did a planning session. So there's lots of planners. Oh, here we go. Here's a developer subagent. Okay, there's its instructions. Read the important files, including the plan. Read test fixtures. Is this what we just saw? No, this is slightly different. Read grep glob. It tried to patch files and failed for some reason. Then patched files using bash instead, or created an entirely new file, it looks like. Planning targeted CLI modifications. There's a problem here with permissions. It doesn't have edit permissions on the files, so it's creating entire scripts to create files, it looks like. Or no, it's just running it directly in Python, entire scripts. That's interesting. Okay, did some grep, did some read, rewrite imprint toggling tests. Okay. Replacing deprecated matcher and adding topology helper. Okay. I still don't see any Context Bonsai calls. Okay, well, at a minimum, this is not one of the problem ones, because the behavior we saw was the developer agent launched. It did just a handful of things, reading, these important files here, and then it appeared to run prune pretty quickly. And this is not one of those. So this is not a good one to keep looking at. So go back to the parent. Okay. Let's see if this tool figured it out. Yep, I checked, and this is exactly a filtering behavior in the script. That exists as a session. Parent ID is null. It's a root session. Interesting. It's a root session, but it definitely wasn't a root session. It was given that the instructions that say you're a developer subagent, here's what you do. So that's interesting. Why it doesn't appear in bun run report sessions. Default mode only prints sessions that have context bonsai activity. Ah, there we go. That's what's going on. Okay, I need to add the dash dash all to find it. Interesting. In that case, that is definitely not one that we care about. There it is. 0 bonsai calls in subagents and 0 bonsai calls in the root session. Okay. Maybe we don't actually have an example. Maybe I was misunderstanding it specifically because we couldn't see the arguments to all of the tool calls, and it simply looked like all it did was read the initial documentation and then summarize that it had read the documentation. If I can't find the actual example of it happening, I'm going to wait until we see it again and capture it right when it happens. Now we've augmented this tool so that we can have more information about what was happening around that call, and we can verify whether or not this bad behavior that I think I saw is actually happening. So in that case, we're going to continue our normal path of doing these projects. I don't need this session anymore. This is where I was going to update the instructions to make it better. So let's just quit this, close the tab. What is this? Oh yeah, this is the tool. We don't need to augment the tool in itself anymore. This is, okay, so now we're back to the main Context Bonsai project of where we're trying to get it not to require direct modifications to the OpenCode itself. Instead, we're going to load OpenCode's own modules during runtime and modify them in place in the runtime rather than having to distribute a modified version of OpenCode just for this plugin to work. And yesterday we had to create a plan that had it go actually figure out how the mechanism behind getting the correct paths that it would need to, I guess, modify and then inject the modified version into the source. So it ran that plan and it completed. And then I asked the LLM if it actually understands what that plan was supposed to accomplish. And the LLM understands correctly, I believe. The core need is to not write a fancy discovery script. It was trying to guess at several things that it could use for importing a function that we need. And that's not what we need. We need to stop guessing and get a trustworthy runtime-specific evidence artifact so we can unblock the real fix for the stock OpenCode prune retrieve. So it was coming up with a bunch of guesses about how it could do it and programming them all, writing tests that they all work. And none of them actually accomplished the final goal. None of the guesses that it made were valid things that could be used, but it considered itself done because it programmed the mechanism itself, and the tests were like they're testing that the detection works correctly, not that it is actually able to find something that we can use. So yesterday I tried to get this to create a plan that would actually find something that was usable. We'll find out if that actually worked. So now I'm going to have it look at the changes that actually happened, see if it meets our needs, and if it looks like it meets our needs, then let's actually figure out how to move to the next phase, which is taking that information of here's how you can get to the module inside of OpenCode that you need to modify and then inject into your plugin. So that is probably going to go off and do a bit of research. And in this side project, the image to maze, this is where we give it an image and we ask it to generate a maze that looks like the image. Yesterday, we went through ways to get it to look visually more like the original image. And we have a new output. Let's see if this does what we want. I also want to make sure in the end, um, it would go through several steps of generating a maze, and it would get a JSON file out of that, and then it would have to convert the JSON to an image, and that created an SVG, and then it would have to create a rasterized image out of that SVG. There were just several manual steps, so I had it implemented as a part of the core tool so that we can have an option there, and that option causes it to generate the actual um, file that we need. However, I'm not sure it actually did that. Because it's specifying a specific JSON output. Oh, okay, no, it's specifying several outputs. Okay, good. So now let's take a look at this image, just make sure that it does what we think it does. Come on, there. That looks good, but it's not marking the start and end, right? We'll zoom in. Right, it's not marking the start and end. Okay. Oh, that was dumb. Here. Yep, the maze does look valid. Okay, good. Oops, not what I intended. Current overlay implementation whitens only the maze path layer and excludes markers, so start and markers disappear in the composited PNG. I can fix this by including the marker layer in the overlay composite, so start and end are visible again. Do it. And I'm not going to go through the normal cycle where it creates a full implementation plan and validates it and goes back and forth until there's no issues left, and then a full development cycle where it goes developer, reviewer, because this should be such a simple change that it doesn't really need to do all of that stuff. Context is now at 54%, which I don't like. It should have been pruning all along. Let's take a look at when the last time it pruned was. Copy this, use our tool. Oops, not what I intended. There. It has done 9 Context Bonsai calls. Let's do the session ID to see what those calls are. And yeah, let's look at the most recent. Refining question pattern, reasoning, refining question pattern. Okay, Context Bonsai prune. Oh yeah, that's a very old one. That one is from 2 days ago. So it's not done any recent Context Bonsai prune tool calls. Oh, that's not what I wanted to look at. I wanted to go here. Okay, yeah, that's still making its changes. So because this still has no additional prune tool calls since yesterday, and we have had it do somewhat different things as it's going along, I would have expected it to have done some pruning already. Once it finishes its current task and we verify that it looks the way we want, I'm going to ask it to not make any further tool calls. I don't want it to spontaneously decide it's time to prune because I'm asking it about pruning. I'm going to tell it don't make any tool calls, and then chat about it around things that possibly could have been pruned away during between the last prune tool call and now. and see if it even recognizes spots that would have been a good idea to prune. Because that's going to help us fine tune that side of things where it seems like the LLM is not aggressive enough in pruning context away. It's running its test. That's great. Glad that it's running tests. Okay, in the meantime, this little investigation where it figured out whether yesterday's plan worked or not is complete. It partially meets our core need, what it accomplished. It replaced hand-wavy assumptions with reproducible artifacts. It now gives strong evidence for what resolves versus what doesn't match in each runtime. It provided a key fact. Current stock path candidates are not importable in the runtime context. Okay, what's still missing for next implementation? The probe matrix still contains wrong assumptions for local internals. Local source shows tool registry namespace, not plugin tool registry, or top level from plugin. Stock artifact shows total miss. Callable equals 0, missing equals 14, which is useful evidence, but not yet a usable injection target. Okay, so we still cannot proceed to implementation of the stock fix without another discovery path focused on actual reachable runtime services. Is there inspection capability to find out the path to an imported module? If so, can we read the file system to find the correct module to import? In general, there is. Useful mechanisms require.resolve package/subpath. Import.meta.resolve package.subpath. ESM if supported by the runtime. Probing package metadata. Okay. Runtime loader traces. Okay. But in our case, with the stock OpenCode, the evidence suggests it's bundled, packaged, so those module specifiers are not directly resolvable from the plugin code context, which Discover keeps returning module not found. So yes, we can and should still do file system assisted discovery, but likely not via normal package resolution. The next practical approach, locate unpacked assets near the binary, if any, and inspect for module files paths. Instead, I want to understand the packaging, like how it works. Maybe we can inspect the package itself. Or the bundle, I mean the bundling. If no module tree exists, inspect reachable runtime objects rather than import paths. Use that to derive patch points from live objects instead of module imports. If you want, I'll run a focused, okay. If OpenCode is bundled, import path guessing will keep failing. We should inspect the bundle directly to find the real internal symbol module names that survive bundling. High-level approach, identify bundler format. Extract or inspect embedded module table symbol strings, locate tool registry session, update code paths inside the bundle output, map those discovered names to concrete probe candidates for the plugin. This is usually more reliable than trying package style imports against a packaged runtime. If you want, I can do this as the next research path and return the bundling mechanism, the discovered internal path candidates, updated probe matrix grounded in bundle evidence. Okay. Does internal path candidates mean the in bundle, what would it be? Symbol paths? Okay. Ooh, it just did a prune on its own. Cool. Let's see. So it pruned away the previous planning, I believe. Oh, no, from the previous orchestration. Great. So we previously created a plan to do all of this discovery stuff, and I told it to orchestrate that plan, and that means it would have launched the developer agent and a reviewer agent and a judge agent several times over until the plan was completed. And that's what it pruned away and replaced it with this summary. We orchestrated implementation and review loops for runtime discovery tooling. The discovery script and tests were implemented and hardened through 3 iterations, ending with judge approval for the tooling itself. Critical retained outcome. Despite improved artifact quality and diagnostics, stock runtime artifacts still show no callable registry updater targets, so the next phase must discover true in-bundle internal symbols before further injection fixes. That is an excellent summary and a perfect example of when to prune and what to prune. I'm very satisfied with that. Okay, so there's its initial plan document. With the user gamut and the needs gamut. Plugin users on stock OpenCode installs who need prune retrieve rights to work without custom forks. That's not exactly what that's quite narrow. What we need is more like, oh, this is talking about the users. Okay, sure. That is one of the users of what we're doing. Maintainers debugging bundle runtime compatibility drift. There we go. That's what I'm looking for. And teams running mixed environments that need deterministic diagnostics and clear go, no-go outcomes. I don't know about that. Evidence-backed target discovery from actual bundle. Geez, OpenCode's automatic scrolling thing is driving me nuts. Maybe that should be a side project. Fixes to OpenCode, where 1, I want VI modal editing. 2, fix it so that when I highlight stuff, it doesn't start auto-scrolling like that. And 3, make it so that if I am not at the tail of the document, it doesn't auto-scroll. It leaves it here so I can just keep reading whatever I'm reading without it jumping all over the place. I wanted to finish the needs gamut. Let's see. Okay, bundled runtime may expose symbols only through loader tables closures, not importable modules. Yeah, some symbol names may be minified, obfuscated. Plan resolves this with multi-method correlation. Okay. Bundle strings, runtime object inspection, and contract probes. Interesting. Okay. And it's going through its validation cycle and making changes, going through again. Okay, this is all doing the right stuff. Back to image to maze. It fixed the overlay. So let's take a look. Oh yeah, it's there, just barely. There's the end. Come on. There's the beginning. And it's barely visible, but still there. So I'm going to go on to the other thing that we needed to do for this, which I already forgot. I mentioned it back when we were looking at this. What was it? Oh, first of all, is everything committed? Oh, I did want to go on to another phase where we take these lines and we restrict them to 90-degree turns. So that could be an interesting thing that makes it look more like a maze and might also make it more look like a typical maze style that looks like a set of corridors with empty space between, rather than this where it's a sort of a thin path outline. No uncommitted changes. Great. To 90-degree turns. Or 60-degree turns. What might be the difficulty in doing that? So one difficulty might be that if it's near the edge of the image, oh, what's happening there? If it's near the edge of an image, like let's say here, it needs to get from this point to this point. So it would have to go up, over, up. Actually, let's think about it more like near the edge of a line that's not 90 degrees. So over here, let's see. Yeah, so to get from here to here, this is a couple of line segments that closely hug the edge of the actual image. And if we were restricting it to 90 degrees, it would have to go like up, over, up, over, up, over, up, over, up in order to more closely hug the edge. Or we're going to miss some resolution, and it would just do like maybe one over and one up. And then there would be a big gap right here between the map and the edge. Generator mismatch currently makes arbitrary angle edges. Constraining to 60-90 means either snapping edges or generating a constrained lattice from the start. Oh, that would be doable, I think. Topology versus geometry tension. Angled quantization can create edge crossings, tiny segments, or merged nodes. Oh yeah, where two segments sort of go like up, over, and up, up, over, and down, whatever. They might cross each other like that. There's tooling that electronics design software uses called auto routing that solves this kind of problem. And I think that tooling lets you have angle restrictions in your traces. That might be a candidate to use here, but that typically looks for optimal tracing, like shortest path kind of stuff, which is not what we want in a maze. But it might work if we're just considering this creates a whole bunch of points that need to be connected, and then it connects those points. And we can just create the points, create the connections, and then say, we need to take this path and convert it to only 90 degrees. Snapping repair heuristics can be order sensitive. Yeah, that's true. In fact, the electronics design software, I think, goes through several, like it happens over and over and over again, and it will create overlapping paths and then like remove all of the overlapped paths and attempt to redraw them. And it can go through many, many iterations and take a while. While building an overlay logic would need to handle the constrained geometry consistently. Stronger angle constraints can reduce silhouette fidelity. Oh yeah, that's what I talked about. Reduce the silhouette fidelity and density smoothness. Feasible, but best done as a deliberate generator mode variant, not a quick post-process snap. I agree. Do you know how EDA auto routing works? Is it appropriate for this? Because in auto routing, you can also, that's very, it needs regions where it's allowed to trace and where it's not allowed to trace, which seems like it would work quite well for this image to map thing. Ooh, it's pruning again. Interesting. Oh, wait, it's not again. This is a whole different project. The last thing we saw was on the Context Bonsai project. Ooh, it's finished its current thing. Done. Created and validated a new plan for the bundle introspection phase. Great. So it says it already validated. It made some changes. I don't think it did the sub. Oh, there's a subagent. Let's ask it to do more validation. Okay. So it's pruning. Oh yeah, that's a thing we need to take care of. Fixing this message ID phase where it shouldn't be doing that part anymore. So it came up with this pattern where I asked it to generate sample data. Oh wow, that's really old. Okay, so this is good. Now it's finally pruning some of the very, very old stuff. And it's probably doing that because the system reminders that get injected get increasingly insistent that now's the time to prune. No, no, now's really the time to prune. The closer, the more full the context gets, the more insistent the messages become. So it finally hit a trigger where it decides it's really necessary now. So this is all the way back several days ago where I asked it to create some tangram symbols to use for this thing. Archived prior completed work. Generated tangram assets. Good. Archived prior completed execution history. Tangram sample creation. Maze generation. I think it's trying to find a unique pattern that matches something that can be pruned. So this is a drawback to the change we made to skip the message ID versions. I think it's trying and failing several times to do the same range, and it's trying to look for unique strings that have only one match in the context. Oh no, nope, this one's a whole different one. Now I want you to generate a maze for the house and the sailboat. Bypassing pruning to answer. I think it failed to prune. That's interesting. I wonder if pruning is failing because when I launched this, the Context Bonsai plugin wasn't in a state that was actually working. And maybe that's why it hasn't pruned yet. No, it has pruned because we did look up how many times this has done pruning. Oh, no, but a session can be resumed and it can, so we can launch OpenCode for a session when the Context Bonsai plugin is working and then exit OpenCode and relaunch it again with the same session, but the plugin is not working. So that's how you can end up with one session where now it's broken, but before it was working. So there were some pruning calls. And I think this means I want our inspection tool to tell us the result of the tool call because it looks like it kept trying and failing. Let's see what happened. Oops. Oh, that's the same one. All right. Here's the session ID. Adjusting pattern to reduce duplication. Ah, now we can see its reason. So yeah, it was trying to find a unique pattern that didn't match several messages. Clarifying change identification, that's the same kind of issue. Planning unique pattern detection. Adjusting pattern to reduce duplication. Yep. Okay, let's see if we can get the tool call result. I don't know if it's like an exit status or return code or what, but we're gonna need that. Okay, so that's gonna augment our tool for us, but let's continue stuff. Here. Okay, so it made more edits, but in the end, it was fine. Okay. Orchestrate it. Okay. Great. It's reading the orchestration documents, planning the placeholders. So those documents require like various placeholders, like what the path to the implementation plan, things like that. What's the path to the developer instructions? So it's figuring out what those placeholders are, and then it will be able to launch a sub agent. There it goes. There's a developer sub agent. Maybe it's a good idea to follow this and see if we see that pattern that I thought we saw yesterday, where the developer subagent starts reading all of these files that it's told to read, digs slightly deeper, reads some code like that, and then let's see if it does an immediate prune or if it actually starts its task. Looks good so far. Turn off dings on my phone. Just noticed that that happened. Okay, what are you doing? It kind of paused. Let's see what the parent is up to. It still thinks the developer is running. Okay. Go back to the developer subagent. It's taking quite a while. Okay, there we go. Looking at git logs. Okay. Or git status. And now, oh yeah, and here's also where we will see if this is having that permissions issue where it can't edit the file. If it is, I want to go hunt that down right away and fix that. Oh, that seemed to work. Created a file. Okay. Sure. And now it's editing files. Okay, it's doing fine. And it did not do that immediate prune call, so that seems to be fine. Okay. Maybe I was hallucinating the issue. Okay. Short answer, EDA auto routing ideas are relevant, but only parts of it for your variant. Auto router concepts are a strong fit. Good fit. Routing on a constrained graph. Treating white regions as blocked keep out zones. Yep. Cost-based path search. Post route, rip up, and reroute. So the rip up and reroute is what I was talking about, where the auto router will have crossing paths and it will rip up. That means like undo whatever path cross and try to reroute it. Less fit. PCB specific electrical rules. Well, yeah, obviously. So use autorouting as a geometry path planning framework, not as is PCB tooling. For us, it's essentially maze on a routing lattice with obstacles and turn constraints, which is very appropriate. Would this be a good adaptation of the Poisson plus MST, or is this its own separate method? I think the Poisson is the thing that picks all of the various locations, the nodes of the map. But then it would use the auto routing to create the things. Ooh, we have to get it to toggle off those message IDs. This should be on its own separate method. You can borrow ideas from Poisson MST. Okay, in that case, there's an overall document that lists methods. Add this to that doc. So that's going to search for wherever that document is, and put this method on there, I'll be interested in trying that one next, because that can probably do some more complex images, such as where there's a keep out zone on the interior of the image. So far, we're using tangram shapes, and the shapes we're working with don't have like windows or isolated islands, which would be like a silhouette area and then a window in the silhouette area, and then inside of that uh, another area where there's supposed to be map or maze material. Um, I am guessing that that's either, well, it's either going to be impossible, or there's going to have to be some link that crosses through the keep out zone. Okay, great. Commit that. And I'm going to restart this session because of that lingering bug where we removed the message ID version of this function. It doesn't have a way to turn off the message IDs unless it can successfully prune. Oh, that reminds me also. Let's take a look at our tool. So it now prints the full tool outputs, and every output returns the there it goes again. Every output returns the status, the arguments, the output, and the error. Great. So let's rerun this and see what happened when it was trying to do this. So, oh, okay. So yeah. So this is the tool. This is the arguments given to the tool from pattern to pattern, the summary, the index terms. Okay, here we go. The output was status 3. Oh, the output was not status 3. The output was 3 messages match output slash house overlay with markers. Use a more precise pattern, reason equals none. And actually, I know what's happening here. This is one we already saw a few days ago, where if it attempts to prune and one of the patterns is fine, but the other pattern has multiple matches, and it refines that pattern to make it more unique and resubmits it, then the pattern that was originally unique is no longer unique, because now there's the original match plus there's the failed tool call that has the pattern in it. We need to fix that actually. Let's do that. And let's add somehow a list. Let's do it over here for now. Bugs to fix soon. Tool call polluting matches. And then the other was message ID instructions. Okay, make sure we don't forget those. Let's go over here. This is still working on the discovery of how we can inspect the OpenCode bundle and figure out how to inject the functions that are needed for modifying OpenCode's message database. Maybe I want to let that finish before I start messing with these other bugs. If this succeeds and it finds a way to inject the function and it can prove that it's actually working, then I will want to finish this this part of making it not rely on the internal OpenCode modifications, of doing the modifications at runtime. If it fails again to figure out a way to do the method injection, the function injection, then I'm going to pause this sort of thread and go do these bug fixes, because the bug fixes are messing up our ability to use the side projects to measure whether the LLM is properly pruning at the right times. And I really want to exercise that part and be able to do that on the side while this heavier, more complicated work is going on. Oh, yeah, and it looks like about time to end the stream because this guy is busy. Oh, this guy's not busy. We can see what's going on here. Oh, no. Yeah, we kind of came to an ending point on there. I think the next thing is going to be implementing our next method. So that's sort of a whole new project to start, and we can start on that on the next session. For now, I'm somewhat satisfied with the current way that this is working. We can generate a maze that looks like the image. The maze fills in the image, and it is valid. You can trace through the various paths and get from the start to the end, and all of these other paths do appear to be reachable, reachable dead ends. And the amount of branching was kind of appropriate. A couple of episodes ago, I traced through one and had to sort of mark several branching points and trace each of the branches to figure out the path to the finish. Um, Something I might want to add in the future is to make it more difficult because right now, in this particular maze, the you can kind of just generally go in this general direction from the start towards the end and usually find the right path easily. I would like the right path to meander through all of the corners of the image, so that it's not obvious. Like if the branch goes this way, and this way, and one of them is clearly pointing towards the finish, then that one's most likely correct. I don't want that kind of thing to happen, and that is kind of what's happening in this current setup because the path doesn't, it pretty much goes from here to here within, I don't know, within this region, and it never goes over here or up here. So that's a potential way to go, but I'd rather try implementing another method and see how that goes. um, but I do want to fix those bugs in the Context Bonsai tools so that it can properly prune, because it did prune at an appropriate moment there and failed. And it really needs to be able to prune at this point. It's at 59% now. It's going to start degrading in capabilities pretty soon. So, yep, that's kind of the next things that we'll be doing on this on tomorrow's live stream. I'll be back tomorrow at 11 Pacific time. Thanks for joining.